Today's lesson is on solving equations. What we're going to do is start with one-step equations. Now, the important thing about an equation, what is it? In the word equation, there's the word equal, equate. And that means that something equals something on another side. So for example, if we say 3x is equal to 9, we are asking ourselves, what can x be in order to make this side equal to that side? When you're solving for equations, what you do is the opposite operations in order to isolate your variable. In this case, this is 3 times x. The opposite operation to 3 times x is 3 divided by 3. Or rather 3x divided by 3. Because it's an equation, whatever you do to one side, you must do to the other. That keeps it equal. Otherwise, it is not an equation. And so in this case, when I divide 3 by 3, these cancel out, and x is equal to 3. And is this correct? Yes. If I plug in the 3 into here, 3 times 3 equals 9. Let's do another one. Let's try z divided by 11 equals 3. We want to find out what this variable z needs to be in order to make this equal and balanced on both sides. Because this variable is being divided by 11, the opposite sign would be to multiply by 11. And so if we multiply this by 11, we must do the same to the other side in order to keep the balance. And here what we can see is that these will cancel out. And so z is equal to 3 times 11, which is 33. And I can check this by plugging in the 33 divide by 11, and I would get my original equation. Let's try something different. X plus 2 is equal to 7. In this case, this variable, what's happening to it is there's a 2 added to it. So the opposite would be to take it away. So x plus 2 minus 2 is equal to 7. And again, we must keep it balanced and therefore do the same on both sides. And this results in x is equal to 5. How can I check this? Well, I can check this by putting in the x back into our original equation. I can call this the left side of the equation and put x plus 2, and the right side of the equation, which is equal to 7. I can plug this into here and find that 5 plus 2 equals 7. Because the two are the same, it means that our variable is 5. Let's try another one. Negative 5 plus x equals negative 8. In this case, again, we are subtracting 5. X is being subtracted from 5, so the opposite would be to add 5. So plus 5 minus 5 plus x equals minus 8, and add the 5 here. And that results in x is equal to negative 3. If I want to check, I will put the left side and then the right side. And we put always the original equation because we want to see if we are correct with this equation, if this variable fits in the original equation. And so let's put in negative 5 plus a negative 3. You should always use brackets when you're replacing a variable by a number. And then here we have negative 8. Are the two equal? Yes, they are, and we've done it well. So that's for the one-step equations. Let's move on to two-step equations. Two steps basically means that you've got more than one operation. And so you have to remember and decide, what will you do first? So, for example, if I have this equation, 3x over 5 is equal to negative 12. Okay. Well, let's see what's happening to the x. This variable is being multiplied by 3 and divided by 5. The opposite would be to multiply by 5 and divide by 3. We'll start with the multiplication. And so we must do on one side, we must do it also on the other. And these will cancel out, and we will have 3x is equal to negative 60. Now, what is happening to this variable? It is being multiplied by 3, and so the opposite operation would be to divide by 3. And in this case, we can then divide these, and we're left with x. Negative 60 divided by 3 is equal to negative 20. And there's your answer. Now we want to make sure that this is the right answer, so let's use our left side, right side. Again, remember to put in the original equation. There we go. Now what we want to do is make sure that when we put in this value for x into here, it'll result with this. So let's put this in, and again, put brackets. And if you do this, 3 times negative 20 is equal to negative 60. And negative 60 divided by 5, I'm losing a space here. Let's just add it over here. And that equals negative 12, which is what we have here, and therefore we are again correct. So in this case it was a two-step because we had to do two different operations. There was the multiplied, 3 times x divided by 5, and what we did was the opposite. We multiplied by 5 and then divided by 3. Let's try another one. 3x plus 2 equals 11. Now, what do we do first? This variable is being multiplied by 3, and then we're adding 2. In order to isolate the variable, do the opposite operations in the opposite order of BEDMAS. Okay, so that means normally we start with multiplication, division, and then adding and subtracting with BEDMAS. In this case, what we want to do is we want to start with the adding and subtracting first in order to isolate our variable. So I can rewrite this, 3x plus 2 equals 11. And what I want to do first, in order to isolate this, I want to get rid of this 2. In order to do that, I will do the opposite operation. And I will go minus 2 and minus 2. We have to do it on both sides to keep it equal. And so now I've got 3x is equal to 9. The next operation that I must do is division, because here it's a multiplication. So I will divide by 3 on both sides and get x equals 3. Now, how do I know if this is correct? We are going to check. So I will check this answer. We've got x equals 3 is what we got as an answer. This is what we have as an answer. So let's do left side and the right side. 3x plus 2 and 11. And now let's replace, again, use a bracket so that you know which operation you're doing. And this is 9 plus 2. And is 9 plus 2 11? Absolutely it is. And so we know that we have correctly solved this, and we are done. Okay? Let's do one more to make sure that we understand how to do this. 5y minus 9 equals 6. Sometimes I say to my students, the opposite operation here and the opposite order of BEDMAS is to do the addition. Or what I will say to them is, take it overboard. And when you take something overboard, meaning over the equal sign, the sign changes. This is a shortcut. You don't have to do this, but if you've understood the concept, it just eliminates some extra steps. So there we go. I've brought it over and it became a positive. And now I've got 5y is equal to 15. The next thing is to divide by 5. And now I've got y is equal to 3. Now what I want to do is to check again, and let's see if it's correct. We found that y is equal to 3. And I will do a left side, right side. Again, write the original equation, very important to keep it to the original because that's what we're checking. And we're going to plug in the 3, use brackets again, and we've got 15 minus 9 equals 6. And as you can see, it works on both sides. And so we've satisfied this equation and we found our variable. Okay, so far we've done 1 step, 2 step. Well, the next one is multi-step.